What if a comet entered our solar system and defied every rule? Imagine an object that seems to break the laws of physics, with a feature that looks more like engineering than nature. This isn't science fiction, it's a thought experiment grounded in a flood of strange data from real interstellar visitors. We're about to explore a hypothetical scenario based on real science that pushes the very boundaries of our understanding. Let's delve into this possibility together. The Chilean frame. It all starts with a single, unexpected image. Imagine an amateur astronomer, much like the legendary Gennady Borisov who discovered the first confirmed interstellar comet from his backyard Margot Observatory, peering at the sky from the clear darkness of Chile's Atacama Desert. The date is October 20th, 2025. Her equipment, a 150mm refractor, is pointed at the coordinates for a newly tracked interstellar object, 3I/Atlas. What comes back from her cooled CMOS camera after a 60-second exposure isn't a textbook comet. The raw data, captured under pristine, verifiable conditions with atmospheric seeing logged at an exceptional 0.7 arcseconds, shows something impossible. This isn't a blurry social media rumor, it's a hard data point from a credible observer. The coordinates match NASA's official Jet Propulsion Laboratory tracking. The equipment metadata is clean, and the image is perfectly sharp. And there, aimed directly at the sun, is a perfectly straight, highly collimated jet of material. This single frame from a small, converted farm building becomes the most important astronomical image of the decade, kicking off a firestorm of debate and challenging the very foundation of cometary science. Comet Physics 101. To truly grasp how radical this new image is, we need a quick refresher on standard comet mechanics, a model that has held up since astronomer Fred Whipple proposed the dirty snowball hypothesis in 1950. Comets are essentially deep frozen reservoirs of ice, dust, and rock. As they approach the sun, solar radiation heats the surface, causing ices to sublimate directly into gas. This outgassing creates the coma. Then, the sun's constant outward pressure pushes this material away. This pressure has two components. The solar wind, a stream of protons and electrons moving at 400 kilometers per second, which interacts with the gas, ionizes it, and carries it straight back along interplanetary magnetic field lines to form the ion tail. The second component is radiation pressure, the gentle but relentless push of photons themselves, which pushes the larger dust particles away. Because the dust moves more slowly, its path is influenced by the comet's own orbital motion, causing the dust tail to be broad and curved. This two-tail structure is a universal signature. No matter the comet's composition or origin, the rule is absolute. The sun always pushes, and the tails always point away. The sunward jet. Now, let's go back to that Chilean frame. It throws the rulebook out the window. Instead of a fuzzy coma and majestic tails pointing away from the solar glare, the image of 3I/Atlas shows something entirely different. The nucleus is a sharp, dark point. The surrounding coma is strangely faint with a measured magnitude of only 18.5, far dimmer than expected. But the most shocking feature is a narrow, focused column of material, no more than 2 arcseconds wide, extending from the nucleus directly toward the sun. It's not a tail, it's a jet. Seasoned comet observers, like the renowned planetary scientist David Jewett, would find this image deeply unsettling. The expected anti-solar tail is completely missing, replaced by a feature that seems to violate the basic principles of solar-driven outgassing. The object is actively resisting a 400 km/s solar wind. The image confronts us with a stark contradiction. An object that should be fleeing the sun's power appears to be pointing something straight at it. This single observation demands an explanation, and the easy answers simply don't hold up. Breaking the rules. So, how badly does this image break the rules? Completely. The standard solar sublimation model predicts that as a comet gets closer to the sun, it gets more active. Light curve models predicted 3I/Atlas should be at a visual magnitude of roughly +8 by now, but it's hovering around a faint +14. That's a difference of 6 magnitudes, which means it is reflecting almost 250 times less light than it should be. Experts like Dr. Matthew Knight of the United States Naval Academy find this baffling. This implies an incredibly low albedo, or reflectivity, of less than 0.04, meaning its surface is darker than asphalt, possibly coated in complex organic molecules called tholins. Yet, This dark, quiet object is somehow powering a highly energetic jet. A disintegrating comet usually turns into a diffuse, messy cloud, not a sharply defined structure. The object is simultaneously too faint to be considered healthy, and too structured to be considered dead. This is a profound contradiction, exhibiting behavior that seems to mutually exclude itself, and it has left our current models entirely stumped. The gauntlet. Every extraordinary claim in astronomy must survive a gauntlet of mundane explanations. The first suspect is always geometry. Sometimes, from Earth's specific vantage point, dust left in a comet's orbit can create an anti-tail. However, anti-tails, studied extensively by scientists like Michael S. P. Kelly during NASA's EPOXY mission, only appear when Earth crosses the comet's orbital plane. On October 20th, Earth was still over 4 degrees away from the orbital plane of 3M Atlas, making a prominent anti-tail highly improbable. More importantly, anti-tails are always broad, diffuse sheets of dust, not the tightly focused jet seen in the image. The next suspect is a transient event, like a pocket of volatile ice erupting. But these outbursts are chaotic and short-lived, rarely lasting more than a few rotations of the nucleus. The sun-facing feature in the Atlas data is persistent across more than 4 hours of observation, making a fleeting eruption unlikely. Finally, atmospheric distortion is ruled out by the observatory's logs. The stars in the image are sharp, proving the sky was stable. After running the checklist, every conventional explanation falls short of explaining the hard data. Chemical anomalies. If the physical appearance is strange, the underlying chemistry is even more baffling. Spectroscopic analysis of 3I Atlas, led by comet physicist Dr. Jonah Lau, has revealed a composition unlike anything ever seen. The ratio of carbon dioxide to water is nearly 8:1. For perspective, cometary experts like Dr. Mike DeSanti at NASA have shown that for most solar system comets, this ratio is less than 0.3:1. This extreme CO2 dominance suggests 3I Atlas formed in a place far colder and more carbon-rich than our own Oort cloud. But it gets weirder. Preliminary spectra hinted at the presence of nickel, but with a conspicuous absence of iron. This has no known precedent. This might suggest the object formed in a region of a protoplanetary disk where elements were fractionated in a way never before seen, perhaps in the ejecta of a very specific type of supernova. This bizarre, hyper-volatile chemistry might explain some unusual outgassing, but it certainly doesn't explain why that outgassing is organized into a single, stable, sunward beam. It only deepens the alien nature of the object. Retrograde path. The object's path through our solar system is, another major red flag. 3I Atlas is on a retrograde orbit, with an inclination of 110 degrees, meaning it's traveling against the flow of planetary traffic. Its immense speed, with a hyperbolic excess velocity, measured at 32 kilometers per second, absolutely confirms its interstellar origin. It's a tourist here, not a resident, but its trajectory, combined with its estimated mass, raises some really fascinating questions. When scientists like Avi Loeb analyzed the first interstellar object, Oumuamua, its slight deviation in trajectory led to the hypothesis that it could be an artificial object, a solar sail. Now, with 3I Atlas, we have a different anomaly. It's not a subtle acceleration, it's a visible, persistent structure that seems to defy solar forces. This sun-facing jet, in the context of its exotic composition and retrograde path, forces us to consider possibilities that stretch natural explanations to their breaking point. Could this jet be a functional feature perhaps, as propulsion expert Mason Peck has theorized in other contexts, an engineered structure for orbital maneuvering? Perihelion blindness. Here's the deadline. On October 29th, 3I Atlas will reach perihelion, and at that exact moment, it will be hidden from Earth, passing directly behind the solar disk. This conjunction isn't just a scheduling inconvenience, it's a period of total blindness for every ground-based telescope. The sun's glare creates a zone of exclusion for optical astronomy, typically inside about 12 to 15 degrees of solar elongation. This is the one moment when any sudden change could occur completely undetected. Experts on solar system plasma environments like Dr. Geraint Jones know that a powerful coronal mass ejection, or CME, could erupt from the sun at any time. If 3I Atlas were to be hit by one during conjunction, The blast of magnetized plasma moving at over 1,000 kilometers per second could strip material, impart momentum, or even trigger catastrophic fragmentation, and we wouldn't see it happen. It's the point of maximum stress, maximum danger, and maximum mystery, and it's happening when our view is almost completely blocked. Space Watchers. Once 3I Atlas emerges from behind the sun in early November, an army of telescopes will be waiting, the scientific community will be on high alert, and the checklist of what to look for is clear. First is photometry. A sudden jump in brightness could signal a natural outburst, while a steady fade, without a growing tail, would be highly unusual. Next is morphology. Does the comet finally grow a classic anti-solar tail, or does the bizarre sunward jet persist? Programs like Pan-STARRS, directed by astronomers such as Ken Chambers, are designed for this kind of monitoring and can detect objects down to a magnitude of 24. They will search for any fragmentation, the appearance of smaller companion objects breaking off the main nucleus. Even tiny, almost imperceptible shifts in its trajectory, measured with a precision of milliarc-seconds, will be meticulously tracked by professional networks. Every new piece of data will be scrutinized, compared, and debated by experts like comet dynamicist David Nizvorny. The weeks following the solar conjunction will be a critical test for all existing theories. Emergence. Assuming 3I Atlas survives its trial by fire, its re-emergence in early November will be the moment of truth. Telescopes worldwide will swing to its expected exit path. Veteran interstellar researchers like Dr. Karen Meach will lead campaigns to recover it, looking for even the faintest signature, perhaps as dim as magnitude plus 24. The most crucial measurement will be astrometry, pinpointing its exact position to within a few milliarc seconds. If the jet has been producing thrust, the comet's path will deviate slightly from a purely gravity-driven orbit. Detecting these non-gravitational forces will be the smoking gun that proves the jet is an active propulsion source. Rapid follow-up spectroscopy will be vital to see if its chemistry was altered by the intense solar heating, perhaps revealing new materials boiled off from its interior. The change in the object, or its stubborn lack of change, will be the key to unlocking this mystery. So, we are left standing at a precipice. A hypothetical object, 3I Atlas, backed by puzzling data from real interstellar visitors, forces us to confront the limits of our knowledge. Is its sunward jet a fleeting natural phenomenon, a sign of exotic chemistry we've never seen before? Or is it something that fundamentally bends the rules of physics, hinting at a purpose beyond natural formation? The period of perihelion blindness leaves us in suspense, but the weeks that follow promise a flood of new data. The answers are waiting out there, in the cold dark of space. What do you think is happening with this object? Let us know in the comments below. And don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our cosmos. Thanks for watching Stellar Tech.